So now that we've made it to the end of the factoring, so the meat of the factoring section, might be a good idea to sort of stop and have a general strategy for how to approach factoring. Okay, so um, what you want to do is, so let me put a title here, how to factor strategy, general procedure. Okay, general procedure. Okay. Um, so the first thing when you approach a factoring problem is to sort everything, to sort the polynomial into descending order. Okay, so that really you want to do that first, and then the second thing is you want to look for a GCF, an overall GCF. If it has one, you want to take care of that right up front. What you do next depends. If you have two terms, then you're looking for the difference of two squares. If you have three terms, then you're looking to see either the trial and error or AC method. If you have four terms, you want to factor by grouping. Okay, so you may at the end also just want to check to make sure that you've taken out the proper overall GCF once you get your answer. There is nothing in common to make sure that you haven't factored, left anything out. So let's take a look at a few examples, one of each maybe. So example, factor. And the first one we'll look at is, say, 5x to the fourth minus 405 x squared. Right. So first thing I notice is it's a two-termer, and I'm now looking to see if there's a GCF. So 5 and 405 certainly has something in common, and because they're both divisible by 5, and this one here, x squared, is common. So I can first take out the GCF. So that will be a 5x squared, and that leaves me with an x squared minus, let's see, 405 divided by 5 is 81. And now I'm looking to see if these are the difference of two perfect squares. So is this a perfect square, x and x? Yes, it is. 81 perfect square, yes, it is. So my A is x, B is 9. So I can now continue to factor this as 5x squared, x plus 9, x minus 9. Number 2. What if we had the problem 3x squared y squared plus 12x squared y minus 36y squared all the way through like that. So again, I'm going to look to see if there's a GCF. So certainly 3 divides the 12 and the 36, so there is a GCF there. X squared, oh, I think I have a typo here. That shouldn't be x squared, that should be x. Okay. There is an x squared there, an x there, so there is no x GCF, but certainly there's a y GCF. There's a y squared and a y squared. So the least power is the 2, so my GCF is going to be 3y squared, and that leaves me with x squared plus 4x minus 9. Oh no, 12. Right? Okay, so now I have a trinomial, 3-termer here, that I'm going to try to factor. So are there numbers that are multiplied to be negative 12? Notice, by the way, a is 1 on this, so I can factor this quickly. Are there numbers that multiply to be negative 12 that add to be 4? So easy to see, negative 6 and 2 will do the trick. And so I can go ahead and factor this. 3y squared x minus 6 x plus 2. And lastly, let's look at this problem. 5rt plus 5r minus 15t minus 15. So this is 4-termer. Let's look for a GCF again. So I see a 5, there's a 5 there and a 5 there. So certainly I can take out a 5. No letters are common all the way through. So this is going to give me an RT plus an R minus a 3T minus a 3. And so I'm going to factor this by grouping because it's 4 terms. So of the first two, r to the first power is the least power of the common letter. So I take it out, t plus 1. And I know this has to be t plus 1. And if that's to be t plus 1, this has to be minus 3. And then I finish up my GCF factoring. T plus 1 r minus 3. So 4 terms by grouping. So GCF first, of course. GCF 4 terms by grouping. This one, GCF 3 terms. And so we can do trial and error, or the AC method. We use trial and error on this one. This one had a GCF and 2 terms. So we used difference of 2 perfect squares. That's it.